Alright, when we finished the last video, basically what we had was this recursive triangle pattern, right? This is called Sierpinski's gasket. And you can imagine, like, you go a little bit smaller. We cut it off at 25. If you cut it off at 10, it's going to get even smaller triangles. If you make this thing bigger, right, you could make it whatever you want, okay? But we're going to add a little funk. Okay, so let's do that. So to get a little funky with this thing, we're going to change the graphics type, okay? We're going to change it to a graphics 2D object. Okay, we're still going to call it G so that we don't have to screw around with any of the G's that we have in here. But what that means up here is that we have to change this graphics object as well. So we're going to cast that graphics object to a graphics 2D object, and then we're just going to go ahead and import that. So that's another AWT thing. And again, if you don't have that way of kind of importing stuff, then here is the import statement for java.awt.graphics2d. Okay, now what graphics 2D allows me to do is, along with some other things, the main thing that we care about right now is that we want to set the stroke of the line that we're drawing when we draw the triangle. Okay, so to set the stroke, we create a new basic stroke object. Okay, and then what that allows us to do is like set how thick the line is. So if we did something like set the stroke to 4, and again we're going to import that bad boy. So that's another java.awt import right there. Okay, basic stroke. So if I set the stroke to 4 and I run this guy again, okay, you can see that those lines are thicker. All right, so that looks kind of weird. But what I can do then is I can say something like, let's make the stroke a function of the distance from A to B. So let's take this guy, move it up here, right? And then let's set the stroke to be that distance divided by, let's say, 25. And I'm using 25 because 25 is kind of our cutoff point down here. Okay. So now what we have is something that each triangle, each sort of recursive step of the triangle is going to be a little bit thinner and a little bit thinner because the distance between the points gets closer and closer. So let's go ahead and run that guy and see what we get. Okay, so there's a little bit of an overlap here. You can see that, but it kind of looks a little bit different. It looks kind of cool. Okay, and then we can keep getting more funky on this bad mamma jamma. Okay, so we can set that stroke, and then maybe the next thing we want to do is like put some random colors in there. So if you wanted random colors, you could do something like this. You could decide that you need so much red. So let's go ahead and go math.random. And we remember that each color is consisting of a number between 0 and 256. Red, blue, and green. So we're going to go math.random, which is a method. Okay. Multiply it by 256. And then cast that to an int. That's going to give me an integer between 0 and 255. We're going to do that for red. We're going to do that for green. We're going to do that for blue. And then we're going to take G and set the color to a new color with that random amount of red, that random amount of green, and that random amount of blue. Okay? And let's run that guy again. Okay, so now you can see it's like super funky. You can kind of see in the background it's not red anymore. It's like some kind of taupe color. Don't tell me how I know about taupe. I don't know. But that looks pretty cool. It actually looks kind of like almost like a stained glass window or something like that. But you can kind of see where some of the colors get kind of washed out by other triangles and stuff like that. But you know, we're just having some fun with some programming. So that's it.